Hi viewers, this is Dr. Jana and you are welcome to our video lectures on Matlab series, and we are going for this image processing. This image processing videos, today in this video we will be covering about the blurring and deblurring of all the things. Before that we can go for this image processing. What we'll take one image, say one image with extension .tip. So we read this image, so this image. Then what we do, we will try to add a point spreading function, we put a Gaussian filter, that is we are first going to blur it using this point spreading function. Then after that we want to go for the deblurring of that one using the deconvolutional Lucy. Okay, so now let us start this program. Now we are using this Matlab, and I am using the online Matlab. You can register and you can work online for some few days. Otherwise you can have a licensed copy of this Matlab where you can use it here also. Now what I have done, I have created my image. My image is gunamani.tip. Okay, this is the image. Already I put it in the current folder, that already it is available, I told you. So here gunamani.tip is there. Any image, so many images I put it here, you can take an image here, right? So now suppose you want to see this one, so just you know the command figure and imshow. What is that? Where you put it, that one, this imread gunamani.tip, it is there, it is stored in the variable I. Okay, then when I go for this function imshow of I, so it will show you the image, that is the first figure, it will come like this. Then for creating a title, use title original image. This is the original image, I put it here, and text size something, and text size I, 2 and size I, 1. So all the things are there. So image courtesy of Gunamani Jana PhD. So all the things you write it here, horizontal alignment, all the things you write it here, no problem. Text size you write it here. Here I am writing BBC R&D Center for Image Processing, horizontal alignment, all the things I put it here, right? So these are the general things. You don't worry for these things. You by the time you will be working on this, no, you will be understanding all the things. Then we are going for creating a point spreading function. So for this point spreading functions, it is the FSF I created. So there I am using f special function. You can see here the comments of the f special function. It gives us the Gaussian filter. So I am using Gaussian filter 5 by 5 size. I am using it here. Okay. Now I am going to using this one. I am going to blur with this point spreading. I created a point spreading function FPSF. So this image I want to blur with point spreading function, so symmetric as well as the convolution, right? So now I put it in the variable blur. Okay, then I go for the showing that blur. So figure imshow blurred. Then the title also I show the blurred. Okay, the first one the title is original image, second one is blurred. Okay, then I go for the deconvolution. So here blurring means just that sharpness will go, some hazy, some smoky like things it will appear, that is the blurring, right? So this is the thing. Then imshow blurred and title is blurred. Then LUC1 you create another variable here, and deconvolute that is blurred PSF5. So using this thing you are going to deconvolute that one. Then this also, that variable figure and imshow Lucy and title restored image and all things. Okay, and here the number of iterations I am putting it 5. See, remember here we can choose because I am writing here 5 is the number of iterations we are using it here. MUIT number of iterations is 5. By default the number of iterations should be 10, but we are using only 5 iterations to get that one, right? Now up to this everything is right, and let us learn. Before I explain you, let us run this program. So I run this program and you can see a number of things that is created here. First one, we go for the figure 1. Figure 1 is the original image. Can you see the image courtesy of Gunamani Jana PhD, BBC R&D Center for Image Processing, right? So this is the original image is there. Then coming to the figure 2, you can see it is blurred. Can you see here the sharpness in the figure 1 and the blurred image? You can clearly understand. Then using this deconvolution blurred PSF in the 5 iteration, I am trying to deblur. Okay, it will not come exactly like that, but it is still improved. You can see it here. Okay, original figure is not exactly like the original figure, but the thing is that we can deblur all the things. Okay, so once again I am briefing this programming what I have done. So first of all I have taken an image and I read this image using this imread function. I put it in I, then imshow I, original picture, that is the figure 1 I have shown it here, because figure means by default it will take figure 1. Okay, then the title I have given original image. You can see the original image it is here, and the text size everything it will come, image courtesy, all things it has come here, right? Then I created a point spreading function. It is just only to add noise to that one. the Gaussian type noise added, and 5 by 5 I put it there. So this gives the Gaussian function, and then what I do using this PSF, I added this is the original image, then I added the Gaussian function, point spreading function, symmetric convolutions. By convoluting all the things we get, and I am using the function im filter. Okay, in this im filter I have all things, and that file is stored in the blot. So the second one is the blot image, you can see here, this is the blot image, right? So then title blot, and then I want to go deconvolution using deconvolution. Then on this blot image I am using again the point spreading function of 5 iteration. Then I am going to get these things, and which you can see it here, it has done it here. Fine. So this is about the image processing part using the blurring, deblurring. Now again I go for another thing here. I am going for another thing, the deblurring here I go for. Okay, I take okay, this I close these images here because this is already over for us. Now yeah, now you know all the things in the command window. We can write it all this CLC, and you can go for the clear, CL, clear, close all these are the default things, so you can put it here. I don't have any problem. So it's clear. You can see in the workspace whatever things are there, it has cleared all this. Fine. So you click it here. Now in this what you read, so I take a image, standard image Lina. So this Lina you can download from this internet, and it is there. So I already downloaded Lina color image is there, and also Lina B, that is the black and white, both are there. Okay, so I hope Lina image is here. Yeah, can you see two Lina and Lina B? Lina is the black and white image, and Lina is the black and white image is the gray value, and Lina is the color image, right? So I am taking this color image, immediate Lina tip. So then I go to crop it. Crop means what is the size of this picture we are taking, that I do not know. I want to crop it to 2 by 50 in the left hand side to 258 55. So it is maximum 0 by 255 or 256 by 256. I want to do it here. Then what I do, then figure IMSO I, then this image it will be shown, that is IMSO I. Then the title I put it the original image. Then I created point splitting functions, F special, the Gaussian 5 by 5. Then I make it blot IMSO I space symmetric convolution thing. So here I am trying to create in the Gaussian, I am trying to create a variation, and variation is given 0.002. So that one using this function im noise blot using this Gaussian. So I think the variation I am giving v is equal to 0.002, it is given there. Okay, then what is the purpose? Adding a Gaussian noise of variance v to the blot image using the im noise function, right? Then the noise variance v is used later to define a damping parameters of the algorithm. Okay, then what I done, so I have everything is stored in the blot image, you can see it here. Then figure IMSO blot noisy, whatever things are there, so I put it there, and in the title I put it the blot and noisy image, right? Then first I taken the original image, then I have gone for the blurring. Then third one I am going to deconvolute, by the deconvolutions I have to deblur that one. Okay, that blurringness or whatever the haziness is there, that I want to recover. So that I store in the variable LUC1, LUC1 which is equal to deconvolution blot underscore noisy PSF, and in the 5 iteration I want to put it there. Okay, restore the blot and noisy images, provided that PSF and using only 5 iterations, default is giving 10, right? So then figure IMSO LUC1 and title restored images. Okay, now it is save it here, and I am going to run this program. If you run this program, you can clearly see we are having 3 figures here, and the first figure you can clearly see this is the standard image. Most of these people who are going for this image processing, they will be acquainted with this face image. So then this is the original image, and after blurring you can see the this is the thing. Yeah, can you see it here, the blur you see already noise is added here. Then I am going to restore that one. Okay, so it is not as the original image, but it is restored to some extent. So this is the things we have done here. Again we are using another thing here. I am going for another thing here. You see, I instead of taking an image, just I taken a checkerboard. So you know there is a option to create the checkerboard here. So I checkerboard 8 by 8 a checkerboard I created. Then point splitting function I added the F special Gaussian 7 by 10. Then VI 0.0001 I simulated 0 mean, that means here we are creating a Gaussian noise. Okay, that is the 0 mean Gaussian noise. So all things I am creating, B is equal to 0, then you can make it 0 point also, there is nothing wrong here, make it 0, right? So 0 point, all the things there. Then blot noisy, then I am using this command im noise. And for what how do you go for the same noise? Infilter of I and PSP using the Gaussian 0 and this variance I am putting it V, right? Then I am creating a weight that is 0, size of I, all these commands I am giving here. Then you see I am using for deconvolution J1, the deconvolution you see the blurred noisy with the point spreading functions 1. Then blurred noisy point spreading functions 20 and square root of V, whatever things I have given the V I created here. Then J3 deconvolution blurred noisy PSF 20 square root of V, and another weight what I created here, that also I am putting it here. Now you know how to make the subplot of that one. So subplot 2 to 1, that is IMSO blurred noisy, that is the first one. Okay. Then the title, gives some title a blurred A is equal to blurred noisy image. Then subplot 2 to 2 IMSO J1 what we created using the point spreading function, we are denoising, right? So that is the subplot, we are using IMSO is equal to J1, title deconvolution using the point spreading function. Then subplot 2 to 3 IMSO J2, title A point spreading function, here I am using N and also DP. Okay, then I am using subplot 2 to 4 IMSO J, title deconvolution A point spreading and L DP and weight, whatever things we already created using all things I am trying to do it here, right? So now before that, because your previous images we can clear all these things, it is not necessary for us now. So once we are going for this type of thing here, and I try to run this program, okay, save it here, this program as it is, and you run this program and you can clearly see, yeah, 3 2 1 and 0, you can see the image which was cleared I, it is not actually original image, it is not shown here, but after adding this point spreading function, that is the thing, the blurred noise, that is it is coming. So that is the blurred and noisy image, it is coming. A is equal to the first one. Okay, then B is equal to you can write it any whatever things are read. Title is the deconvolutions APSP. So this is the second image, it is created. Then third one, we created the deconvolution APSP NI and DP. So this is there. So deconvolution APSP and using the weight also we are putting here. All the things you are able to do it here. I hope you can see in the workspace all the things, what is the blurred, deblurred and J1, J2, J3, you see point spreading functions, all the things you can see the value and the size and the class also double or unit, all the things you can see it here. I hope we have enough stuff. Okay, if you one more thing you want to see this deblurring using some techniques, I think this already I have shown to you, the restored image and all things, linear TV I have shown you. So using all the things you can have at least sound knowledge about how to go for this loading the image and creating some checkerboard like things, and how to add the noise and how to go for the deblurring. Adding the noise means you are making it blurring, and then we are going for the deblurring using the different techniques. So thank you very much for watching this video, and if you do like this video, please do share with your friends, and also don't forget to subscribe this video. And it's based on your response only I will try to make some more videos on this image processing. It is very much useful for the MTech people, and especially who are planning for the research in the leading to PhD degree. So it is very much useful to them. Thank you once again. Please take care of health. Have a good day. Bye.